Hello students, welcome back to my channel. Today we'll study the topics of JAM differential equation, that is we will learn about existence and uniqueness theorem in differential equations of especially of second order, and we will also learn about Wronskian, some of its properties with examples. Now let's get started. Existence, uniqueness theorem. Given the differential equation P naught x y double dash plus P1 x y prime plus P2 x y is equal to Q of x for x belonging to a domain D. Then first condition, where P0, P1, P2 and Q are continuous on D. Second condition, P0 x is not equal to 0 for all x belonging to D, basically the leading coefficient. Then there exists two linearly independent solutions y1 and y2 such that any solution of the differential equation would be the linear combination of y1 and y2, where y1 and y2 are power series and x minus a raised to power n, and y2 is equal to Vn x minus v raised to power n, टेलर सीरीज बेसिकली, जैसे कि cos की जो फॉर्म्स होंगी या e रेस्ट पावर x के टाइप में हमारे पास कोई सोल्यूशन आता है तो उसकी हमें सीरीज आती है. cos x की सीरीज क्या होती है 1 माइनस एक्स स्क्वायर ओवर 2 फैक्टोरियल प्लस एक्स रेस्ट टू पावर 4 फैक्टोरियल एंड सो ऑन. e रेस्ट टू पावर x की क्या हमारे पास होती है 1 plus x square by 2 factorial plus x cube by 3 factorial and so on. And sin x की क्या होती है हमारे पास 1 minus x cube by 3 factorial plus x5 by 5 factorial minus and so on. जैसे कि अगर हम एग्जांपल कंसिडर करें y डबल डैश प्लस y और ऊपर वाली डेफिनेशन में these a and b belongs to capital D is equal to 0. इसमें जो हमारे पास होमोजेनियस इक्वेशन आएंगी दैट वुड बी ऑफ द फॉर्म c1 cos x प्लस c2 sin x. तो सीरीज अबाउट 0, ये भी हमारे पास टेलर सीरीज यहाँ पे हम यूज कर सकते हैं. एंड सिमिलरली वी ऑल्सो नो दैट इट्स जनरल सोल्यूशन कैन ऑल्सो बी ऑफ द फॉर्म cos x माइनस a plus c2 sin x minus b. So around a और around b टेलर सीरीज एक्सपैंड कर सकते हैं हम cos और sin की. अब सिमिलर कंडीशंस के साथ, ये कंडीशंस के साथ we also have that then there exists a unique solution satisfying, क्या satisfy कर रहा है वो y x naught is equal to a and y dash x naught is equal to b. इसको हम कहते हैं इनिशियल वैल्यू प्रॉब्लम. On the other hand, if x belongs to a comma b and we have been given that y of a is equal to a dash and y of b is equal to b dash, then it is known as boundary value problem. और इस केस में solution may not be unique. Now, इनके एग्जांपल्स देखते हैं. वो पहले वाला ही इक्वेशन लेंगे y डबल डैश प्लस वाई इज इक्वल टू 0 और हमारे पास इनिशियल वैल्यू प्रॉब्लम है y ऑफ 0 इज इक्वल टू a एंड y डैश ऑफ 0 इज इक्वल टू b। कुछ भी सेट कर लेते हैं हम तो हमारे पास एक यूनिक सोल्यूशन आएगा, जैसे कि y was c1 cos x plus c2 sin x, y of 0 is a c1 and y dash is minus c1 sin x plus c2 cos x, which in turn implies b is equal to 0 plus c2. Hence, we have a particular unique solution a cos x plus b sin x. And in case of boundary value problem, we have y of 0 is equal to 0 and y of pi is equal to 1. Then in that case, we have 0 is equal to c1 plus 0 and y of pi is equal to 1. 1 is equal to minus of c1. In this case, we have no solution. If y of 0 is equal to y of pi is equal to 0, then we will have infinitely many solutions because 0 would be equal to c1 and in another case also minus of c1 would be equal to 0, which in turn implies y is equal to c2 sin x is our solution with infinitely many solutions. We can also have unique solution in this case if we take y of 0 equal to 0 and y of pi by 2 equal to 1. In that case, we have 0 equal to c1 and 1 equal to c2, which in turn implies y is equal to sin x is the unique solution. Why these conditions are important? We take an example, that is x cube y double dash minus 3x y dash plus 4 y equal to 0, which in turn implies theta minus 1 plus 3 theta, यहाँ पे माइनस ही ठीक है, plus 4 is equal to 0, which in turn implies theta square minus 4 theta plus 4 is equal to 0, which in turn implies theta minus 2 square is equal to 0. That is theta is equal to 2 and 2. Y is equal to c1 plus x c2 x raised to power 2. Now, if we take conditions to be y of 1 is equal to 0 is equal to 1 and y dash of 0 is equal to 0. In first case, we get arrive at a contradiction that is 0 equal to 1. ये हमारे पास बेसिकली ऐसी क्यों आई है कॉन्ट्रडिक्शन? बिकॉज यहाँ पे ये जो लीडिंग कोएफिशिएंट x के ये इट बिकम्स 0 एट 0, तो हेंस 0 पे हमारे पास प्रॉब्लम आ रही है, हेंस वी कैन नॉट गेट a unique solution. Therefore, these conditions were important. Now, with the initial conditions, y of x naught equal to a and y1 of x naught equal to b, where y is c1 y1 plus c2 y2, for differential equation p0 y double dash plus p1 y dash plus p2 y equal to q, where p0 is not equal to 0, we have a is equal to c1 y1 plus c2 y2 at x naught and b is equal to c1 y1 dash at x naught plus c2 y2 dash at x naught. इसको मैट्रिक्स फॉर्म में अगर लिखना हो then it would be y1 y1 dash, both are at x0, y2, y2 dash at x0, c1, c2 equal to a, b. This is a, x, and this is capital B. A unique solution will exist if determinant of A is not equal to 0, that is y1, y2, y1 dash, y2 dash at x0 is not equal to 0. This is also known as Wronskian. y1, y2. That is, if Wronskian is not equal to 0, then we have a unique solution. While if Wronskian is equal to 0, then we have no solution or infinitely many solutions. Now, if we take an example y double dash plus y is equal to 0, we have y is equal to c1 cos x plus c2 sin x. If we take the Wronskian, cos x sin x minus of sin x cos x is equal to cos square plus sin square x, that is 1, which is not equal to 0. Hence, we will get a unique solution for any of the initial value problem. Now, when we get a unique solution, then the situation is intersecting lines linearly independent, and we get a unique solution. Wronskian is not equal to 0, that is determinant of A is not equal to 0. Now, if determinant is equal to 0, then we have two cases. Either we have infinitely many solutions, or no solution.